Alright, welcome back to Meteorology 101. As everybody's talking about the winter storm that's coming, we're going to look at some charts, upper air level charts and surface charts. Here's the current radar. Let's back this up, play the radar, and you can see through southern Illinois, Indiana, into southern Ohio. It's a pretty good little amount of snow coming in that direction. I'm not sure what they're expecting. They're about an inch or so. I'd look for pretty much just moving through pretty fast, so probably look for an inch. 2 inches is the most, depending on how heavy this gets. Looks like it's drying out even as it gets into the future cast. So the current time is 6 p.m. and going up to 8:15 p.m. So we're only about a half hour away from where it's supposed to be for the future cast, and then we still have a little bit of a area that's going to be pushing through. So see what kind of accumulation we're looking for on that. We'll look at some models, and we'll show you how to determine the precipitation amount, how to actually forecast it, not just based off of what the Weather Channel says. So there's the current radar. We'll come back to this radar and put that on the current slot so we can compare this to the models. If we get into the models, if we got time, then we can compare this to those models and see how they're initializing with the precipitation, and compare that to our surface chart and see how they initialize with the surface chart also. Alright, so with the weather program, I'm going to pull up the current surface chart. We're going to start with sea level pressure. We're going to see where our highs and lows are located at. Maybe throw some fronts on here temporarily. The fronts on this program is computer generated. I can draw fronts, but that takes a little bit of time. And I think what I can do is just draw on the screen, and I'll show you where the front should be placed. Look at the thermal advection. So here's our high pressure system that we were looking at for this cold Arctic air. This is what's dropped our temperatures. This is an elongated high pressure system. This actually is picking up 3 different highs. So we're looking at, there are some areas in this high pressure system that are actually a little bit higher or lower pressure centers than just one big long high pressure. That's why this chart is actually bringing up 3 different high pressure systems. Now, the only way to have high pressure systems next to each other like that is if you have a really strong ridge or trough that separates the two, or maybe a stationary front. Because if you look, your winds circulate clockwise around the high. So if the winds circulate clockwise around this high and then around that high, then the winds are going to oppose each other. You're going to get a lot of wind shear. So you're looking at, right there is the troughing off of the low pressure system over the 4 corners. That's an inverted trough, and that's coming up into that area. And I would say going into basically maybe a little bit of stationary front there. I don't even know if I'd place a front there. But the troughing separating the 2 high pressures. The only reason this chart is picking up a little bit lower pressure in the center of that big elongated high. We have a 1030 millibar high, 1029 millibar high. And let's see if we can see the upper one. There's a 1040, so it'd be a 1044 on that line. So that's a pretty strong high. That's the Arctic air. That's what's going to push this low pressure system. Is going to push off. This high pressure is going to push in, and then that's where we're going to get those single digits that we're looking for in a few days. So here is, let's get up back to center here, and we can throw our isotherms on there. And now we can see the thermal advection. So if you look around this low pressure system over the 4 corners, all these isotherms are running pretty much parallel with the isobars. So where there's not a lot of thermal advection there until you get down here into this thermal troughing, and then this troughing, inverted trough, pushing up into the Ohio Valley. Now, if you, like I said, the high pressure circulation around the high is clockwise. So all this wind is coming up from the south, pushing all that warm air to the north. So you got the warm air advection being pushed up, and then you have a big cold air mass elongated through the northeast United States. Now that warm moist air being pushed up over that high pressure system. That's giving it the lift. Once it cools to the saturation point, then it will fall through that cold air and fall as snow. So the areas that it falls as snow all depends on the thickness lines. We're looking for the 540 line. We'll pull up a thickness chart here in a few minutes and get a good look at that. That's just a rule of thumb. And then right now I'll throw the surface plots on, and we'll see what we got for stations, what some stations in those areas are reporting now. So just looking at this real quick, you got the red areas are IFR conditions. That's really low ceilings or really low visibility. So this one, if you can see a couple lines in there, that's reporting mist. There's reporting snow in southwest Kansas. We look around these highs, we want to look for winds too for rotation to see if that high pressure center is there. I see a wind out of the west, one out of the southwest, then these winds coming out of the north. So this right in the middle of that high, that's maybe like a 5-knot wind. So it's kind of irrelevant there. Anything from 0 to 6 knots is just can be pretty much variable. But looking at that rotation, I would say, yeah, there is definitely some rotation right there for a high pressure system. So we are reporting snow in central Iowa, moderate snow northern Illinois, nothing in Indiana. I don't have all the plots on here. If I put all the plots on there, you wouldn't be able to see this map. So St. Louis is reporting light snow. Like I said, all the way back down into southwest Kansas is reporting snow. So. And then you got low ceilings, low visibility. You've got mist, dropping that visibility at least below a mile. I think it's below 3 miles when it turns these red, and then 1 to 3 miles when they're blue on the visibility, and then when it's black, it's anything above 3 miles. And then the ceilings also will cause these colors to change too. So, like I said, winds from the south going around this low pressure system, around those highs, and pushing all that warm air advection to the north and then going up over that cold air. And when it saturates, it falls through. That's when it becomes snow. So that's the latest service chart. Let's throw the fronts on there real quick. Just see what these computer generated fronts do. They may be a mess. I don't know what it's going to look like. Did I hit it? Try it again. I don't have anything. So maybe my fronts didn't get downloaded. Alright, we're not going to download those right now. That's going to take too much time. So we're just going to go ahead and move up to the 850. I'm going to throw some moisture on here first, see where the 850 millibar moisture is. That's going to give us an idea of what's happening in the upper levels. So it's pretty dry around the Gulf. That low level warm air advection, any of that moisture being pushed up is pretty much down toward the surface, or at least below 4,800 feet. All the moisture to the north, this is what's already in the upper atmosphere, right around 4,800 feet. So all that's going to push through. Any of this becomes saturated. It's pretty much saturated. That's why the moisture is on here. So any of that, those drops become too heavy to be held suspended, then they will fall to the ground. They'll fall through that cold air mass and fall as snow. So real quick, let's go do a thickness chart real quick. We want to see where that 540 line is. That's going to give us an idea of what areas we're going to see any of this fall, where it's going to be snow or where it's going to be rain or any kind of mixture. So let me go pull up a thickness chart. That will take just a few seconds to build that. Actually, let me erase that if I can in time here. Get rid of that moisture. This one just takes a little bit longer because there's a lot of data that processes through this. Okay, so these are the thickness lines. If you look at the purple line, that's where that 540 decameter line is. That's going to be your rain and snow line. So we got snow to the south of that, so that's already pushed south. That's already changed since this data was put out. So right along that line is where you'll have a mixed precipitation. Anywhere north of that line will be snow, and anything to the south will be rain. But it still puts the surface pressures on there, and then we're just looking for that line for the initial idea of where we got. So right there through central Missouri, they're always on the line. Right there through Kentucky, southern Illinois, central Missouri, northern Kansas, and then into northern central Colorado. So it just gives you an idea where that snow line is. Now, as this high pressure pushes south, or this low pressure starts to fill, as all this changes, then that line will move. Now, what's likely to happen, this high pressure is going to continue pushing through. So that's going to just build this ridge. So you're going to get pretty much some cold air damming here. That warm air pushing from the south, all that warm air advection is running into that high. That warm air can't move the cold air, so it's just that cold air is just going to create a dam, and you're going to get that warm air just kind of push up against it and create that damming. So let me go back, and I also want to pull the sea level pressure real quick and pull the surface isotherms real quick, and we can, since we didn't download the fronts, they'd probably be pretty messy on here anyway because there's a lot going on. Let's go ahead and see if, I don't know if it's going to let me draw them or not. I will try without crashing the system. Okay. Now, if we look at the thermal advection, this is an inverted trough right here all the way up into the Ohio Valley. Warm air advection, low pressure system. Let's go get our surface plots on here. I just want to analyze the surface chart pretty good because I want to see what's going on. We didn't see any moisture to the south at the 5,000 millibar or 850 millibar, 5,000 feet height. So I just want to see what's going on. We definitely got moisture because we got marginal BFR down along the coast. We have broken to overcast skies through the south, and then we get up in here to where that warm air starts pushing up over that ridge. Now that's where we're getting the lower ceilings and lower visibility. So with these charts, look at this wind shift right there. Wind out of the north, and then all of a sudden wind out of the south. So $31 degrees, 65 degrees. I mean, there's definitely some cold air right there. That's definitely like a cold front. Like I said, we got all this warm air being pushed in from the south, running up over that ridge. Strong wind shift, but we got ridging right there. I mean, there's really no, I mean, there's definitely a separation in the air mass, but I mean, where do we bring our, we'd have to bring a front. I want to see where this is, all the way down through, out of that low pressure system to the north. There's a pretty strong shift. Not really strong, but it is a shift right there. You'd be pretty much at a occluded low. Really weak advection, not much going on there. And then you have to bring that cold front all the way down. See what our temperatures are here. 24, 15. That's winds out of the south. Winds out of the northeast. That's probably, that's not rotation there. That's not a, definitely not. We got winds out of the south, winds out of the north, ridging. I'd have to say it's cold air. This ridge is just pushing that cold air right down through here. That warm air is just bunching up against that and overrunning that. This is all warm air advection. Wind shift. Winds out of the north, winds out of the south. I mean, you pretty much should take a warm front right here. I mean, right out of this low. Right across these wind shifts. Right through that trough. Right through that trough, and there's all your warm air advection. And then if you had anything to the south, but there's really nothing going on down there. I wouldn't worry about that. You got just cold air, warm air advection right over that ridge. Like I said, when that becomes saturated, it's going to fall through that cold air mass and just freeze. And then depending on your freezing levels, if you're going to get mixture, freezing rain, ice pellets, snow, or rain. Alright, let's get moving here. Let's get up to the 850. And it wasn't very impressive on the fronts. It's hard to place fronts on that. You got a developing low pressure system to the southwest, and then high pressure just dominating through just an elongated high pressure system through the central United States like that, and then a big strong low pressure system to the north, and then a low pressure system off the coast. I mean, it's just a lot going on there. You could throw them fronts way back over off the coast, and then bring a stationary front back up and connect into a warm front. You know, that's probably would make more sense. Alright, let's get some moisture on here. I'm trying not to keep this video going too long. We're 16 minutes in. We just hit the surface. Alright, so we got the moisture well to the north. Let's do pressure on 5,000 feet. Alright, so high pressure, we got ridging. And then that big, huge system to the north. That system is just crazy up there in Canada. Pretty much up in the Arctic. That's where you got this big, strong, high pressure system. It's basically on the surface, just pushing through. And then you've got troughing in the upper levels. I mean, so you're not... This thing isn't even... The high pressure system, the heights on that thing is so low. I mean, it's still below 5,000 feet, so all it has to have is like 1,200 feet to become snow. So if any of that precipitation falls through 1,200 feet of cold air, anything below freezing, then you're going to have snow. There's some plots on here real quick. So you can see all the moisture. -3, -7, -21. You see that cold air in the upper levels dropping pretty quick up to the north. So we got all of our moisture to the north. So here, if this system is going to move to the northeast, the high pressure system is going to push in. Any of this moisture moves to the northeast, the low pressure system, upper level, lower pressure, pushes over that high pressure system, and then any of that air cools to saturation, which it pretty much has. Like I said, all it takes now is these water droplets or ice crystals to collide and start building each other, and then they'll get too heavy, they'll fall through that, and there's snow already. So they're just going to fall right through that air mass and remain snow, and you can get some pretty good snowflakes out of that. So looking for basically the system continue to push east, so that's going to be the predominant flow, as it usually is. Weather travels from west to east throughout the United States. So all this is going to push over, and then this upper level trough pushes over, creates any kind of lift to keep those particles suspended long enough to become bigger particles as they collide and then fall into that air mass. Now you're looking at any precipitation through the Ohio Valley, Indiana, Illinois. Now you're going to get your few inches of snow. So let's go back up one level. If you look at, well, now we're going to throw fronts all over the place. Okay, so let me get rid of this. Okay, so let me throw the well, we got the plots on there, and let me throw the see what kind of thermal convection we got. We got some baroclinic clinicity going on to the northeast. We got a lot of this stuff starting to become parallel with these isobars, these contours, upper level contours. You got a little bit of weak warm air advection at 5,000 feet. So warm moist air being pushed to the north over a cold air mass, that's going to give you, like I said, that more snow, and then push over to the east. Then you're going to get that system that's going to develop and push right through the east and then to the northeast, and where you'll get most of your snowfall. So let's go up another level, see where our moisture is. We're not going to spend too much more time on this. I don't think I'm probably not going to go all the way up, but we might take a look at the jet stream just see where we're at. So we do still have significant moisture over northern Illinois, Indiana, and Ohio, and then we have over the Great Lakes region. So let's go ahead and real quick throw some pressure on. And you can see your flow. So any system that's moving down is just going to push straight to the east. That's your flow. This 700 millibars. The middle level flow is your steering of your low level systems. Now, if you look at the isotherms now, they are almost parallel with those contours. So there's really no thermal advection. A little bit to the south, pretty weak, but we still have significant moisture over the Great Lakes region. That's at 700, and then we'll put one more and we'll run the 500. 500 is a significant level, about 11, or that's about 18,000 feet. So if we got moisture at 18,000 feet, now you got significant moisture all the way up to the upper levels. If anything, you get into a low level jet, go up to 300, you start getting into the jet stream, and then once that jet stream starts supporting all this system, then you can count on a pretty good system to develop. Like if we have that low pressure system over the four corners, that could spin up along that front. If we had the front coming through, like we said, with the warm front connected to either that low pressure or stationary, that thing develops and shoots off of that mountain range and then back over to the east, and then we got the jet stream picks it up and gives that support. It could develop into something pretty strong. So we still have significant moisture at the 500 millibar. I do like to throw just some pressure on here, see what's going on, and then it's probably just going to be straight again. We got some troughing from the upper level low. That system, that's not really an upper level low. That's just still a closed low in the upper levels. That's stretching all the way into the upper levels from the surface. That's the predominant feature on these maps. Outside of that cold Arctic air, that high pressure just elongated through the north central United States, that's just that's your cold air mass. Any precipitation that's falling, that's what's making the decision that it's going to be snow. And then temperature lines, pretty much parallel, nothing really going on there. So now we're definitely parallel all the way through. Now that system becomes barotropic in the upper levels. What that's telling me in the upper levels on that is that system's pretty much lived out its life. It is, once it becomes barotropic, then that low pressure system starts to fill, and then all that stuff will start weakening, and then that front that's off the east coast, that will start to undergo frontalysis and fall apart and become stationary most likely at first, and then just fall apart. So then what you're looking for, that stationary front or any frontal system that's going to be going across the southern United States where that low pressure was over the four corners, or a lee side low on the lee side of the mountains, anything that gets over top of that a front that is starting to decay or become stationary, you could definitely get another low spin up off of that, and then have a whole nother system develop, and then just push to the northeast and bring all that moisture off the Gulf and just drop tons and tons of snow. Now, I haven't seen that in a long time. 1993 was that pretty storm of the century that just dumped feet of snow. I mean, it dropped a lot of snow in that year. So, and that pretty much devastated the northeast United States to New England and just put the power out for weeks. One more chart here I want to look at too is I'm going to look at the 500 millibar, the vorticity chart. That's going to tell you any upper vertical motion indicated, and that's going to give you an idea. If you threw the surface front chart down, and then you threw vorticity on top of it as a composite, then you can pick up some areas that you might get that development along that front, if there's a front there. So this one looks like vorticity off the coast to the north, Great Lakes region, a couple little spots over the central United States, and then you do got some just over Idaho that could affect that low pressure system that was over the Four Corners area. That's where which you're going to have upward vertical motion there because you do have that low. So not real impressive here though. I mean, there's nothing really strong outside of that way up to the northwest. So the Great Lakes region, you got that moisture, you got upward vertical motion. That's just holding that moisture aloft. The more that holds that moisture aloft, the bigger those drops can grow, and then you can get some bigger flakes for that fall. So, all right, let's get out here. Let's go look at well, let's go real quick. I want to see I do want to see the jet stream. Let's go up to the 250. So the jet pretty much just covers the United States. But here is, so we had the high pressure system to the north. Ridging, we had all that ridging going on too in the central United States. Then we had that inverted trough. So this one is pretty much troughing, the long wave trough, and then you have that jet max moving out of the trough. So that's another indication. Once that jet max moves out of that trough, then you'll get that low pressure system up there just start to fill. That's kind of a rule of thumb there. So throw the temperature lines, you're not going to see anything on temperature lines. That's all going to be, should be parallel with the contours. Some little pockets, cold pockets up there. 56-degree cold pocket right there. And jet max 125 knot winds, 125, 135 knot winds right there. So through that jet max, pretty strong winds upper levels. All right, so let's go to our forecast models. I do want to see, like I said, with this radar, I want to see not the one I want. Let's go radar. All right, let me get rid of this models thing real quick. Okay, so if we look at that, and then we look at these models, we want to compare these two. So over Illinois, Indiana, and Ohio, that thing's got like one big blob. There's a couple little holes in there, so that's kind of initializing okay on that. And then that low pressure system that was over the Four Corners, it is showing that low pressure system over there too. So these are initializing okay, not too bad. Let's go ahead and play them out. Let me get rid of the radar, get that out of your way, and we can push this through. See what we got here. Okay, so we're all the way back. This is 0Z, 7 o'clock tonight. It's about an hour behind right now. And it's got that system, basically that moisture, looks like intensifying into some pretty moderate snowfall over the Ohio Valley, southern Illinois and Indiana, mixed down into southern Missouri. Central Missouri, you're looking at light snow. And still some moderate snow pushing off, and then just most of that stuff dissipating. And then the low pressure system, looks like a low pressure system just develops right there, right off the coast of Virginia. As soon as that gets over the water, that becomes a pretty, that's not real intense, 1013 millibar low. But that can all change. I mean, these are models, so you know the depth of those low pressure systems and stuff, that's all kind of irrelevant really. Look at that 540 line right in the middle of the screen. That's what you want to keep an eye on. Any moisture to the north of that's going to be snow. So push these models through. Now we got Now we got more of that warm, moist air pushing up from the south, and then that high pressure pushing in from the northwest. That's what's colliding, and then that warm, moist air being pushed aloft by the high pressure system and then being pushed through. Anything that falls through that's going to be snow. So right back into the Ohio Valley. This is for 12Z, 7 o'clock in the morning on the 11th. That's on Thursday. Let's go back a couple. 18Z, that's like 1 o'clock on Wednesday. So you're starting to get into some mixture stuff picking up, a little bit of areas of some light snow, just some scattered areas of light snowfall. You have to, this is, like I said, this is, you got to take this with a grain of salt too. I mean, these are models. So if you say it's going to be light snow at, this is 7 o'clock Wednesday morning over central Missouri, that snow may evaporate before it hits the ground. You may or may not see that. You may see a few flakes, stuff like that. So, but as the system starts to develop even more, these basically you got that trough, the inverted trough, and then you have the ridge from the Arctic air pushing to the south. Those two start colliding. That's where you'll get that line of mixture, and then anything to the north, once it gets high enough, that freezing level gets deep enough, then any precipitation that falls through, that's going to be snow. So that's where your line's going to be. Now you got the mixture, looks like all through southern Illinois, Indiana, and then a little bit into Ohio, but Ohio looks mostly like snow. And then as that cold air pushes through and pushes that freezing line to the south, then you're getting into more snow. And now you got a pretty strong area through Kentucky, West Virginia, and Virginia of looks like a lot of icing going on there. And that could be, depending on those freezing levels and the depths of those freezing levels, if there's going to be warm levels, warm layers between those freezing levels. If you have more than one freezing level, then you can have, snow falling through a warm layer, partially melting and refreezing before it hits the ground, or just freeze all the way and become snow again before it hits the ground, depending on the depths of those freezing layers and warm layers. So, all right, this is 06 for Friday, 1 o'clock in the morning, and looks like Virginia is mostly mixture, except for to the north, the DC, and then pretty much throughout Ohio. The Ohio Valley looks starting to dry out a little bit. But out of all of this precipitation, that's what I think they're saying, 2 to 4 inches. Now, here's what system coming through. We got a low pressure system developing over the four corners. Lee side troughing. Looks like high pressure just dropped down, and then it just loses the low, then it regains it over Kentucky. I would say probably keeps that thing together the whole time, and then pretty much the same thing. Warm air advection just pushing over a cold air mass. So your low pressure system, wraparound moisture, that's a system to keep an eye on. Let's see where we're at here. Missouri looks like you're going to get some pretty moderate snowfall, probably a few inches there. I have to see what the precip models are showing for amounts. We'll go over that in just a second. Then that low pressure shooting off to the northeast. Then high pressure just dominating the central United States. And I'd like to see some temperatures there. Let's see if this thing shows me anything. This tropical tidbits thing is supposed to show you, to be able to pull some soundings. Usually you can click on this thing and pull some soundings, but it's not letting me, so I'd like to see what their surface temperatures are in the middle of the high pressure system. So that's 0Z on Tuesday the 16th. So 7 o'clock at night on the 15th. Monday night. I want to see what that see what we're looking at there. Alright, so that is the forecast models. Let's get over to here's another forecast model, GFS. I'm going to pull this one up for you, and this will help you see how much precipitation is going to fall. It gives you a good idea. The GFS goes a little strong sometimes. The GFS, if you get a few days out like that system coming through, like Tuesday or Wednesday, that's going to be this may be more accurate now because the GFS does a better, sometimes does a better job in a few days out. So we can't scroll through like we did with the Tropical Tidbits. These are just graphics that are loaded. These are from Monterey, California. The Navy puts these out. So if you look at the greens, 2 to 4 millimeters, 4 to 8 millimeters, 8 to 12 millimeters, and then you go higher from there. But keep an eye on what type of precipitation you have, and then match it with the color, and you go 2 to 4 millimeters is pretty much what you see in these areas. So now we get into a little bit lighter green, so 4 to 8 millimeters. 8 millimeters is about 5/16 of an inch, so just over a quarter inch. Quarter inch of rain, precipitation, quarter inch of rain would be like 2.5 inches of snow. So in the Ohio Valley, you're looking at previous 6 hours, about 2.5 inches of snow through that in Indiana. Looks like just south of Indianapolis. And then the green, 2 to 4 millimeters, looking about an inch or so all the way stretching up through Ohio into Columbus. Now this is for one forecast model, so it's a 6 hour previous precipitation fall. So it's forecasting what would have fell in the last 6 hours, and then it puts it on this chart. So that's 0-6Z so from 0Z to 6Z, basically saying 2.5 inches of snow, because the 540 line's to the south. It's putting it well to the south, and that being all snow, and then that would give you 2.5 inches of snow Tuesday from 0Z to 6Z. So 7 o'clock at night to 1 o'clock in the morning. Now that could fall, within an hour. That could fall within 2 hours. It doesn't really specify. It's just saying what fell in the last 6 hours, what it's got an idea of. So then you come up to the next chart. Now you got, we got another area. There's a little bit of lighter green in there, but I wouldn't be too concerned about that. I'd say 2 to 4 millimeters. So if you're looking at 2.5 inches of rain of snow, then half of that, then you add that to the 2.5 inches, so now you're looking at 3 3.75 inches of rain. This is by 12Z, 7 o'clock in the morning on Tuesday. That is tomorrow. So we could have a pretty good snowfall by 7 o'clock in the morning. And then pretty much dries out, and then just patchy stuff to the north, to the south, and then there's that low pressure system that we were showing. Looks like that once that gets off of the coast, that becomes a low pressure system, becomes closed, and then becomes a pretty intense system out there over the ocean. Alright, so now Wednesday, 18Z. It's like 1 o'clock in the afternoon on Wednesday. On the 10th, now we got another little bit of a precip coming through central Illinois, and then pushing into central northern Missouri and central Indiana. We'll see what happens now. This is that other system we were talking about going through, like Wednesday. This is Wednesday night at 7 p.m. So now you're looking at another, 4 to 8 millimeters, so another 2.5 inches of snow there. And that's all through the Ohio Valley. I mean, by the time it's all said and done, that's not going to melt. That first batch isn't going to melt 2.5 to 3 inches of rain. We could end up with 5, maybe 6 inches of rain here, or 6 inches of snow. So the Ohio Valley looking like it's getting hit pretty good here this time. And then it's starting to push south. 540 line still to the south, and then over the mountains. Obviously, you're going to get more snow over there. And then pretty heavy rain through northern Louisiana. And then this system developing, what is this, a low popping up, or just some troughing warm air advection from the south. And then that becoming an elongated system, mostly rain to the south. So we got there 12 to 18 millimeters of rain. That's almost 3/4 inch of rain over Louisiana and Mississippi. And that's all rain down there. So, and that is Thursday night and a Friday. Alright, I think that pretty much does it for this video. Went a little bit longer than I wanted to. Hopefully you learned a few things. I probably made a few mistakes. Forecasting right off the models, you gotta be careful with that. A lot of people do it. I like to make sure they're initializing well. These do look like they're initializing well, so I kind of stuck with them. Nothing like the real-time data once you get into pulling these surface charts. Hopefully next time I can pull some fronts for you. I'll get a little bit better with the drawing system on this thing, and maybe we'll pull up some surface charts, analyze some fronts, do some frontal placement, get a better look at this tomorrow. We'll pull up some more of these charts and go from there. So give me a thumbs up, like the video, share, subscribe, all the good stuff, and thank you for watching.